Which we will, but all right. This is our next speaker, Forrest Norville, and he is going to talk about the deep, dark internals of Node, where he has spent way too much time.
That seems like an accurate summary. All right, I'm Forrest Norville. I work for New Relic. I am New Relic's Node team. I've been working for the last year building out the instrumentation for Node for New Relic. If you aren't familiar with our product, it's an application performance monitoring solution, so it can give you insight into your application and help you figure out why it's not going as fast as you would like. Like I said, I've been spending the last year working on the Node.js agent for New Relic. I've been using Node in one form or another since 2010. I have to say that since coming to New Relic, I have kind of transcended in terms of my knowledge of Node, and that's really a matter of sheer necessity. Writing tooling is a difficult problem, and trying to figure out how to write tooling that does something tricky in an always asynchronous environment like Node is even harder when you can't actually allow anything to happen to the code that you're putting the tooling in. Our job is not to tell you how to write your code. Like, my job is not to tell you that CoffeeScript is dumb or that you shouldn't be using Express or whatever. Like, I may have personal opinions about some of that stuff. That's irrelevant. Our job is to build tools that help you make stuff that will make your code run faster and help you figure out that for yourselves. Really, this talk has got a couple purposes. One is to kind of stress what I've decided are some good patterns for writing modules that are meant to be used by other people, particularly tooling, and also to try and kind of get you guys to level up a little bit so that it's easier for me to work with your code. So there's a certain amount of self-interest involved with all of this. So writing an agent for New Relic actually is really easy. It just has to not crash. It has to be easy to use. It has to be really easy to deploy. It has to run fast. It has to stay pretty small. It has to work like our other products across the offering. It has to run synchronously when everything else around it's running async. It's got to be deterministic. It can't start doing weird things under load. I got to be able to troubleshoot it when things do go wrong. You can't really conflate concerns too much because you have to be running other people's code. It can't alter how people's programs run. It can't change the environment that it's running in. It can't depend on very much outside of core. And it really shouldn't care how your code is written. Easy, right? Yeah, in practice, it's really not so much. There's a lot of trickiness that most of you, if you're lucky, will spend very little time worrying about because it is stuff that is buried deep within the guts of Node. So what I'm really going to try to tell you about here is not so much New Relic, but like, how do you write code for other developers? How do you write code that's meant to be consumed downstream? How do you write code that other people can pick up and extend and work with and do cool things with? There's a really big problem that you have to face first, and something that I didn't really notice until I started reviewing my slides this morning is that this talk is really not so much about Node. I mean, there's some Node-specific stuff, but really not a pure language. It is neither one thing or another. You know, it's possible to use functional programming constructs. You can write monads in JavaScript if you want. You can bring all of this cool stuff in that's like super fun to play with. We've heard about some of it over the course of the last 2 days. It's also possible to use inheritance. If you want to bring in one of the many transpiled languages, you can actually even get something that looks like real classes. That doesn't mean that either is a good idea on their own, and it definitely doesn't mean that using them together is good or easy. So one of the big problems is object orientation and functional programming don't necessarily get along. One is based on the notion of encapsulating state inside objects and mutating that state over time. Functional programming, by contrast, is about data flow and it's basically about abstracting over time. You want things you want the data to flow through. Each thing does one step. And a lot of the assumptions that you can make when you're doing functional programming, particularly when you're using a lot of higher order functional programming constructs like monads, is that the world is going to remain invariant while you're going through this functional flow, which completely conflicts with how JavaScript wants to work. So when you have all of these cool techniques, you got to be careful. Another thing is that JavaScript is fully dynamic. This is a lot of what gives it both its simplicity and its power. But at the same time, like if you are used to using a strongly statically typed language like F# or OCaml or Haskell, that does a lot of the bookkeeping for you. So you can use all these cool things like applicatives and bananas and lenses and like scrap your boilerplate style, higher order data type polymorphism, all these cool things that Haskell nerds like to talk about when they're hanging out together being cool. The problem with those is that you have to do it all up here when you're doing it in JavaScript. You don't have the runtime to help you out unless you want to write a whole bunch of extra code. I don't know how many of you are familiar with the programming language Roy, but this is a transpiled environment that Brian McCann put together to bring a lot of these kind of higher order functional things into JavaScript. And it's fun right up until you run into a brick wall when it's just saying undefined is not a function, and then you have to figure out what's going wrong. There's no tooling around there to help you. The real problem here is that complexity is your enemy. When you're writing a module, I mean, it's true to a lesser extent when you're writing applications and you're just consuming modules. But when you're writing things to be consumed by other people, any sort of like fanciness, cleverness, all of these things that make you feel smart and awesome are going to make life hard for other people. You want to make it as dumb as possible without abandoning the power given to you by your platform. So writing tooling is a special challenge. Like, tooling can't break. People will not trust your tool if it crashes on them. I get a lot of slack because I'm still haven't hit 1.0, and also because writing tooling is also a very hard problem, and people generally understand that. But, absolutely my highest priority, and it should be your highest priority if you're writing something that's going to be consumed by a lot of people, is if it's crashing the runtime, you have to stop everything, fix that, deal with it, move on. Almost as importantly, you can't change anything about the behavior of the system. Like, one of the things I've spent a lot of time working on is making it so that things crash consistently. If something crashes when it's running on its own, it needs to crash when it's running under my code, and it needs to crash in the same way. I can't just capture an error and do whatever I'm doing with it and then swallow it. It has to keep propagating that, because I don't know how you're going to be dealing with this stuff in your code. And like I said, this simplicity is super important also for performance. Because JavaScript is this weird mongrel language, there are all these things that we talk about to kind of do that, like, wrap everything up in closures, or do all this fancy stuff with dynamic properties, or like create like weird proxying strategies, or use like a front end like Tame.js to like add another layer over there so you can do your control flow. Those things are awesome when you're writing applications and are doing your own benchmarking, but when you're writing something that's going to be used by somebody else, you want to be doing stuff that may look a little more procedural than you're comfortable with, but at the same time, is going to work well with V8. And another point kind of on the side here is there are tools that are available to you when you're writing applications and have full control over your stack and its runtime environment that just aren't available when you're writing tooling. So you've got to think a little bit harder about how you're going to get the information back to you as the tooling developer, while at the same time like making it so that it's easy for people to still use this thing and work with it. This is something that I have learned, like, the more I know about how V8 runs, the better the node developer I become. And I kind of skipped over the part where I linked to these slides. At the end, I'll point out the URL. All of these slides are available up on GitHub, and I've hot linked all this stuff. Vyacheslav Yegorov's blog, that's Mr. Aleph, and Andy Wingo have spent a lot of time talking about how a JITted runtime works, and specifically how V8 does its magic. And like, once you can talk with confidence about how Helium and Lithium and Crankshaft are doing their jobs, you will have a huge tool in your toolbox for like figuring out what's actually going on with your code, and you can start using some of the more exotic V8 command line options like trace deop to actually get to performance problems. Also, the node debugger isn't perfect, but it's a hell of a lot better than just trying to do everything with print statements, and it's not actually that scary. It doesn't always work. There's a lot of weird interactions because it's basically just the V8 debugger, but if you can get in there and like don't try to like step off the end of the event loop and watch the debugger go off to the moon. You can still learn a lot about the state of your running programs using that. And Node Inspector is also a nice tool that looks an awful lot like WebKit Inspector because it reuses a lot of the same plumbing. I spend all day with a window with the node.js source file and node.cc open. And I spend a lot of time switching between the two. That is probably the most complicated part of Node, and it's something that you have to only be very tactical about working with. But actually understanding how the event loop is working and understanding the difference between process next tick and set immediate and a lot of those other tools that I'm not going to get into right now will save you a lot of time in the long run if you're trying to write something that runs close to the metal. And kind of as a converse to that, don't try to use Node's core programming patterns as a model for your own development because it has been tuned for performance over any other priority. Like especially with 0.10, a lot of the stuff in the node.js file is done to make things very fast. Trevor Norris has put an awful lot of work into speeding all that stuff up, but the flip side of that is it's really hard to figure out what's going on. So don't write code like that. Just learn to understand it. So I've kind of sketched out like the tools that you can use and what the problem is. Here's some of the stuff that I've actually used in writing the agent that might be useful to you as well. First off are some pretty basic tools. UStrict is like a little magic pragma that is part of ES5 and is implemented in V8. It will cause the runtime environment to behave much more strictly. You can't use things like arguments callee and a lot of the kind of metaprogramming things that Brendan Eich thought was a good idea 13 years ago and have caused a lot of people a lot of pain since then. The 1-2 combination of UStrict and JSHint will tighten up your code a lot. It doesn't really matter if it's JSHint or JSLint. Choose a lint or choose some sort of static analysis tool and use it. Because JavaScript is just, there's too many degrees of freedom. You need to box it up so much so you don't write code that is doing something that you don't understand and don't respect. The debugger, like I said, and actually if you're trying to do benchmarking and profiling, like don't use something like JSPerf. The tools that are built into the Node source tree are kind of unwieldy, but they will do the job and they will give you much better numbers. And like, I can't really get into it right now, but Isaac has spent a lot of time like describing why those tools work the way they do, why the numbers always get bigger, like think about things in terms of throughput rather than timing. But those are great tools and they give you a much more realistic view of how your code's actually going to perform in the real world than trying to use some of the online benchmarking tools. Also, Node's got some great core abstractions. I mean, this is something that Substack talks about a lot and a lot of the other people close to core do, but event emitters are a great way to do control flow. Like an event emitter and a counter, you can do an awful lot of things that you might use a control flow library for. Streams are a great abstraction. I find myself using them in ways that I'm pretty sure they weren't designed to be used. At the very least, learn to get comfortable with piping things around and writing enough of a readable or a writable stream to use pipe. And also domains. Domains are something that are very near and dear to my heart. I've spent a lot of time learning to use them because they are very good for doing the kinds of like propagation of state I need to do. I'll get into some of their limitations. I have a whole other presentation that I've given at other places that I link to from this deck. But they're really useful, and I don't feel like people have done enough with them yet. Also, V8 is an ECMAScript 5 runtime, and that means that there's a bunch of stuff built into it that you might have to use a library for if you're writing browser code. I know some of this may be completely obvious to a lot of you, but these are things that I've found that a lot of people don't know. I've seen a lot of y'all's code in the last year, and sometimes it can be a little scary. So I just want to make sure that I kind of hit all these high points. You've got your basic collection, and iteration methods built in there. Object keys is a great way to ignore about 10 pages in Crockford's book. Just use that, and then you never have to worry about var in and has own property or any of that crap. And function.bind, like I actually got in some conversation with some people last night. This may not be the fastest way to deal with the problem of this in functions that are going to, function scope means that when you're enclosing something, this suddenly means something different than it would in an enclosing scope. You can do the old var self equals this trick, but if you use function.bind, this always points to what you want it to. I use this a lot. It may be a little slower. It's a lot easier for me to understand, and it makes it a lot easier for me to reuse the callbacks that are bound that way. You can refactor the code a lot more easily that way. So something I do a lot is monkey patching. And this is a term that mostly comes from the Ruby world, where they also tend to use it a lot, probably too much. And this is something that I have to do a lot to write instrumentation, because that's how I get my instrumentation into your code dynamically. There's a right way and a wrong way to do it. This is the simplest way that I think most people are familiar with. Just grab something off a prototype, replace it, call the original. There are better things you can do to make this safer. So the first thing is, don't throw, and try to write your code defensively enough that you can trap all the things that might throw and just return early. That is by far the most important thing, because this is the sort of thing that suddenly you're introducing a vector for failure into your module, right? Before it was doing whatever it was going to be doing, but like now, if you are making some assumptions about things that don't prove out, then you've made your module crash, and it crashes user code. That's bad. Log everything. I don't care what logger you use. It could be console, it could be whatever else. But the thing about monkey patching is that it adds additional indirection and complexity to your programs. And if you aren't logging stuff, then you're going to end up either having to step through an endless chain of deferral as you kind of go through various stack frames trying to like step through it in the debugger, or you have to like go in and add a bunch of logging after the fact anyway, because it can be really difficult to understand what's happening in a monkey patched or metaprogram module. Leave visible traces behind. Once you've wrapped the function, stick a property on the side saying that you were there, so that if other people are coming along later in the debugger, they can see that they're dealing with a wrapped thing rather than like the original object. The next one's kind of like related to that. You want all this stuff to be idempotent. So if you want to make sure that you're not trying to double wrap methods, you want to make sure that you are not unwrapping something that doesn't have your wrapping. There's one trick to this, which is if you look at my unwrap function there, if somebody comes along after you've wrapped the function and wraps it again, you're not only going to unwrap your stuff, you're going to unwrap their stuff. So be aware of that, but once you're in a situation where multiple people are monkey patching the same thing, you're kind of in crazy town. So don't do that, I guess is the best thing I can say there. Also, this is something that is probably like something that only I care about, because it's bitten me on the ass a couple of times. But always return the result of wrapped calls. Even if you think it's a callback that no one is ever going to use the return value, you've looked at the source and you know that it's nil, like someday that's going to change, and suddenly your stuff's not going to work anymore, and it's going to take you forever to figure out what's going on. All right, next thing, keep it simple. Don't metaprogram in JavaScript. Like, I think there are probably a lot of people in this community that come from the Rails world or Ruby world, where that is like where all the fun is. You know, Perl people write poetry, Vim people golf, like Ruby people metaprogram. So I've got this little syllogism here. You got magic is bad, magic is also super fun, metaprogramming is magic. So of course, metaprogramming is super... Oh, wait, no, that's not right. It's bad. So now I'm going to talk a little bit about why. Here's a really great example. I have tests for my code, and I like to try and use Mocha as much as possible because I am a former Ruby person and I like RSpec. So I try to do all this stuff, but if you run tests under Mocha, it includes everything into one kind of address space. It runs them all in one process. So if you've got, say, Restify and you've got Express in the same spot, they both like to start dynamically sticking properties on the request and response objects, and eventually one of these web libraries is just going to stomp on the other and put something in there, like maybe it's a status text or something like that, and you don't know which one's going to win, and you've managed to introduce some kind of race condition into a single-threaded environment. Good job, everybody. So, this is a good object-oriented design technique in general, but try to compose rather than extend. This story will be a little different when ECMAScript ES6 finally comes out, because it has proxies, probably. But like in general, like build a container for something and pass it around out of band, or do something similar instead of just sticking random properties on things. Object-defined property and define getter and define setter and proto, like these are awesome tools for like creating magic. Like lots of people like to make like should has a DSL where it's using getter functions on define property. That can really, really, really confuse people. And then this last one is another one that's kind of specific to my experiences. So quick show of hands, how many of you know what I mean when I'm talking about functionarity? Okay, good, most of you. There are two very popular modules or frameworks in the node space that do this. Mocha and Express. In Express's case, it likes to see like how many parameters there are in your middleware. What's the problem with this? Well, it actually does dispatch based on how many parameters there are for the function. And so if you want to monkey patch the thing that's doing that dispatching, then, I'm starting to run a little low on time. Okay. Then you have to basically create a whole set of monkey patch functions that have all those different arities, because you can't set function.length. Right? Like you can't set the length on a function after the fact. You have to actually declare a function expression with that number of parameters. So like it's cool, and like the fact that you can have your tests in Mocha either be asynchronous or synchronous depending on whether you've got the magic parameter in your callback is awesome and all, but like, and I use that all over the place, but in general, don't do that if you're writing something that's meant to be used or debugged by anybody else. Here's another one that's kind of controversial, maybe. I mean, I know it's really fun to argue about which control flow library is the best. I don't care. Like, they're all equally great and equally terrible to me as a tooling developer. Just use one and stick with it. Just conflate, like the problem is when people are trying to conflate like async with promises with step, or like they're like, oh, I guess I'll just try playing around with Streamline here or whatever. Like when they're combined, it gets really difficult to understand what's going on. Also, can we just stop talking about this? Use what you like. Don't use what you don't like. Don't yell at everybody about it. And it doesn't have to be a 64-message thread on the mailing list every time this comes up. Like I said, there's a whole other presentation about domains, but there's something I've learned after working with domains for a long time, which is that there is enough power in the domains module for you to do all of your error handling via domains. And that is actually pretty awesome, because that means that you've now taken the 4 or 5 different ways that you can be signaling exceptions around and like smoosh them down into one thing. But totally awesome. Domain intercept, almost nobody knows about it, but like with domain intercept, you basically pass in a callback that takes the typical error, everything else parameters, and it just strips off the error and then re-emits it on the domain if it gets one. Totally cool. Also, you can use them for other things. Like I've tried to use them for transaction tracing, and I won't get into what that is because that's a whole other conversation. But that's a conflation of concerns, because you're using them for error handling and you use them for something else is not what they're good for, especially because they try to behave as much like real-world exceptions as possible. Again, like handle errors one way. If you have any just use domains as much as possible. Please, everybody start using domains. They're totally awesome. I don't know. I mean, the documentation around them is maybe not still super great, but they are here to stay, and they're a really useful tool. That second one, try clauses like can't be optimized. That's what that means. Like the catch clause. Like, let me slow down just a second. The cool thing about using domains is that you don't need the try clause anymore, because your exceptions will automatically propagate up and be trapped and re-emitted on the domains. And if you are layering the domains, then they will catch that and they will take care of all this stuff for you. Also, everyone needs to pretend that uncaught exception does not exist. It's an anti-pattern. Isaac doesn't like it. It's deprecated, and people use it for all kinds of strange and bad things. And my last point is, I don't want to be like a dick about this. You could write your code however you want, but make sure that you're publishing JavaScript. It is the one language that we all share in common. even if you don't use CoffeeScript in your day-to-day development process, I mean, if you don't use JavaScript in your day-to-day development process because you're using CoffeeScript or TypeScript, it is the thing that is actually being run, and it is the thing that you are consuming when you're using packages from NPM. And actually, kind of a further step beyond that, just write JavaScript. It's not the best programming language in the world, but it's good enough. Keep it simple, keep it safe. That's basically all I got for you. There are all the links. There's my domains presentation. Down at the bottom, that's these slides, and there's a bunch of presenters' notes, and there's probably a lot more opinionated ranting that I probably shouldn't be exposing to the public in there. Something to look forward to. Thank you very much.